Allow me to explain what is requirements analysis before I move to other topics in this video. Requirements analysis allows software engineers to define user needs early in the development process. It helps them deliver a system that meets customers' time, budget, and quality expectations. If you are designing a system or a software program, you might want to know how to analyze its requirements properly. In this video, we shall review the requirements analysis process and explain various analysis techniques. In another definition, requirements analysis is a set of operations that helps define users' expectations of the application you are building or modifying. Software engineering professionals sometimes call it requirement engineering, requirements capturing, or requirement gathering. Requirements analysis involves various tasks that help engineers understand stakeholder demands and explain them in simple and visual ways. It is essential to a software or system project's success. For a project to be successful, its requirements must be testable, actionable, documented, measurable, traceable. Requirements analysis involves various stakeholders, such as project sponsors, throughout the project as well as end users whose inputs are most important. The best results typically occur when all parties work together to develop a high-quality requirements document. Requirements analysis, requirements engineering, is the process of determining user expectations for a new or modified product. It is usually a team effort and demands a variety of human soft skills, such as critical thinking, communication, and judgment. Requirements analysis is a common and essential concept in software development and software project management. At the start of every software project, it is critical for the project team must understand, finalize, and document the features and functionalities required of the end product. These required features and functionalities are often called functional specifications, and the process of determining and understanding them is called requirements gathering and analysis. Requirements must be quantifiable, as detailed as possible, and relevant to the end product. In addition, they should be documented so the development team has clear expectations and understands the required specifications from the beginning. Requirements analysis and feature creep. Requirements analysis and clear communication help to prevent feature creep in software projects, also known as scope creep. Feature creep refers to the addition of excessive features to a product, which often makes it overly complex and difficult to use. Feature creep is usually the result of poor planning, insufficient communication, inadequate requirements analysis, and poor understanding of requirements by the team. It complicates product design, undermines its value, and can eventually make it unusable for end users. To avoid such problems, project teams must gather, understand, and analyze the product's requirements before development begins. Requirements analysis or requirements engineering is a process used to determine the needs and expectations of a new product. It involves frequent communication with the stakeholders and end users of the product to define expectations, resolve conflicts, and document all the key requirements. Requirements analysis is a multi-stage process that involves the following 6 steps. Step 1. Understand key stakeholders and end users. In any project, the key stakeholders, including end users, generally have the final say on the project scope. Project teams should identify them early and involve them in the requirements gathering process from the beginning. Step 2. Understand project goal. To capture all requirements, project teams must first understand the project's objective, for example, what business need drives the project? And likewise, what problem is the product meant to solve? By understanding the desired end, the project team can define the problem statement and have more productive discussions when gathering requirements. Step 3. Capture requirements. At this stage, all relevant stakeholders provide requirements. This can be done through one-on-one interviews, focus groups, or consideration of use cases. Project teams gather stakeholder feedback and incorporate it into requirements. Step 4. Categorize requirements. Categorization of requirements can help with prioritization, impact analysis, feasibility analysis, and conflict resolution. Let me list out 4 common requirements categories that exist. Functional requirements, technical requirements, transitional requirements, and operational requirements. Step 5. Interpret and document requirements. Interpretation and analysis are easier when requirements are well-defined and worded. Each requirement should have a clear and understood impact on the end product and the project plan. After all the requirements have been identified, prioritized, and analyzed, project teams should document them in the Software Requirement Specification, SRS. Step 6. Finalize SRS and get sign-off. The SRS should be shared with key stakeholders for sign-off to ensure that they agree with the requirements. This helps prevent conflicts or disagreements later. Feedback, if any, should be incorporated. The SRS can then be finalized and made available to the entire development team. This document provides the foundation for the project's scope and guides other steps during the software development lifecycle, SDLC, including development and testing. The system development should be complete in the predefined time frame and cost. SDLC consists of a detailed plan which explains how to plan, build, and maintain specific software. A wide range of intricate models used in software development are represented by the SDLC. Practically speaking, SDLC is an all-encompassing methodology that addresses the various sequential steps required to produce a software product of superior quality. In this video, we shall look at 7 stages of software development lifecycle in detail. Stage 1. Planning stage. It is good to take your time and fully grasp the app development lifecycle before you even start the planning step. The planning stage, also known as the feasibility stage, is precisely that, the time when project creators will make plans for the future undertaking. Determining the goals for their new systems and defining the problem and extent of any current systems are helpful. Stage 2. Analysis stage. During the analysis stage, all the specific information needed for a new system is gathered, and the initial concepts for prototypes are identified. This covers every detail of the hardware, software, and network specifications needed to build the system they intend to develop. This will stop them from using excessive funds or resources when they collaborate with other development teams in the same location. Stage 3. Design stage. Usually, what starts out as an SRS document gets transformed into a more structured version that can be implemented in a programming language. Plans for operations, maintenance, and training will be created so that developers are aware of what needs to be done at each step of the cycle going forward. After everything is finished, development managers will create a design document that will be used as a guide for the next stages of the SDLC. Stage 4. Development stage. The actual writing of code and construction of the application in accordance with the previously created design papers and detailed requirements takes place during the development stage. SAST tools, or static application security testing, are useful in this situation. The design document specifications are followed when creating the product program code. Stage 5. Testing stage. Developing software is not the last step. It needs to be tested now to ensure that there are no issues and that there will never be a point where the end-user experience suffers. Developers will sift through their program with a fine-tooth comb during the testing phase, identifying any flaws or defects that need to be recorded, rectified, and then retested. It is crucial that the final product of the program fulfills the quality requirements that were previously outlined in the SRS document. Stage 6. Implementation and integration stage. The software's general design will come together after testing. Developers will work to integrate various modules or designs into the main source code, typically by using training environments to find further flaws or faults. Stage 7. Maintenance stage. This may involve addressing lingering defects that could not be fixed prior to release or fixing brand new problems that emerge as a result of user complaints. In comparison to smaller systems, larger systems could need longer maintenance phases. Stage 4. Development stage. The actual writing of code and construction of the application in accordance with the previously created design papers and detailed requirements takes place during the development stage. SAST tools, or static application security testing, are useful in this situation. The design document specifications are followed when creating the product program code. Stage 5. Testing stage. Developing software is not the last step. It needs to be tested now to ensure that there are no issues and that there will never be a point where the end-user experience suffers. Developers will sift through their program with a fine-tooth comb during the testing phase, identifying any flaws or defects that need to be recorded, rectified, and then retested. It is crucial that the final product of the program fulfills the quality requirements that were previously outlined in the SRS document. Stage 6. Implementation and integration stage. The software's general design will come together after testing. Developers will work to integrate various modules or designs into the main source code, typically by using training environments to find further flaws or faults. Stage 7. Maintenance stage. This may involve addressing lingering defects that could not be fixed prior to release or fixing brand new problems that emerge as a result of user complaints. In comparison to smaller systems, larger systems could need longer maintenance phases. The process of identifying user expectations for an application that has to be developed or adjusted is called requirements analysis. It includes every task carried out in order to determine the needs of various stakeholders. Thus, requirements analysis refers to the process of examining, recording, verifying, and overseeing software or system requirements. Common requirements analysis techniques include 1. Gap analysis. Gap analysis involves comparing the desired business goal to the baseline. It studies what the business is currently doing and what it wants to achieve. Analysts perform this investigation to identify gaps in performance and find ways to optimize it. A gap analysis defines things like the current state of the project and where the company wants to be. It gives the business a better understanding of how it can improve. 2. Business Process Modeling Notation, BPMN. Business Process Modeling Notation is a popular method for improving processes. The technique is similar to creating process flowcharts but with a set of elements and symbols specific to BPMN. It allows teams to create graphs that simplify their understanding of the business process. 3. Flowchart technique. The flowchart technique describes the sequential control logic and sequential flow of a group of related activities. Flowcharts can represent system interactions or data flow, for instance. They are easy for both technical and non-technical team members to understand. Flowcharts come in multiple formats, including top-down, cross-functional, and linear. 4. Unified modeling language. This is a set of diagrams that helps teams visualize, specify, build, and document a software system's characteristics. UML provides a standardized method for visualizing a system's design. It uses diagrams that represent data such as structural information, behaviors, and interactions within the software. The UML technique helps validate the architectural software design. 5. Role activity diagrams, RAD. A role activity diagram is a modeling technique showing the roles people play in each step of the development process. It uses diagrams to capture an organization's structure and dynamics. RAD groups software development activities by the tasks each role performs. If you have enjoyed this video, don't forget to visit our online educational platform at www.eduslides.com by registering for free courses. Guess what? You can as well earn a certificate of completion after completing your course, and you don't have to pay to register. Why not subscribe to our YouTube channel to get more videos by clicking the subscribe button below?